pairing of d electrons. Fine, there will be pairing of d electrons. I will explain you what is the meaning of this. So ammonia has approached cobalt. Now ammonia is a strong ligand. Now because ammonia has come near cobalt 3 plus, okay, what will happen? Pairing of electron will take place in the d of the d electrons. So electrons will shift over here. This electron will shift here. This will shift over here. Fine. This only happens, students, when there is strong ligand. So ammonia is a strong ligand. Now, so we are having d orbital 1, 2, 3, 4, 5. So how many electrons are there in the first? 2, second also 2, third also 2, and this 2 will be empty. Okay. Now we have 4s and we are having 4p. Fine. Now what is going to happen? Ammonia, NH3, 6 ammonia ligands. We all know that each ammonia is having one lone pair of electron. So these lone pair of electrons will be given over here. Okay, will be donated. Okay, but this will happen when there is hybridization taking place. Okay, so which hybridization will take place over here? It is d. How many d orbitals are there? 2. S and p 3. Okay, so hybridization is going to be d2sp3. Now d2, 2 plus 1 plus 3, that is 6. Okay, so in this case the geometry is octahedral. Now please make a note of it. Now what I am going to speak. In this case, there is pairing of electron happening because the ligand is strong. Hence, after the complex is formed, after this particular complex is formed, what happens? There is no unpaired electron, isn't it? So I will write absence of unpaired electron. Okay, there is no unpaired electron in this complex. Now because there is no unpaired electron, see, no unpaired electron is there, what will happen? This particular complex is diamagnetic. What does it mean? That it is going to repel the magnetic field. Okay, magnetic field. It is going to repel the magnetic field. Fine. If this complex is brought in the magnetic field, what will happen? It is going to repel that field because there is no single electron. Now, so it is diamagnetic in nature. So we have to remember this, and because there is no unpaired electron, electrons are not going to spin here and there. It is known as low spin complex. Okay, low spin complex, you have to remember, when no unpaired electrons are there. Okay, low spin complex, or we say spin paired complex. It means all the electrons are paired. So I hope this particular compound you have understood. We will understand the same concept with more examples. Now the next complex is there in front of us. It is hexafluorocobaltate 3 ion. But what are we studying? We are studying the structure and bonding. So let us start with the first step. First step is what? Find out the oxidation number of the metal ion. So I wrote X. Now fluorine is F minus 1. Okay. So minus 1 into 6 would be minus 6 is equal to minus 3. Alright. So X is equal to plus 3. It means that in this complex, students, in this complex, we have CO plus 3 charge. Okay. Now CO plus 3 charge is there. So it means what will be the electronic configuration? Just now we have done. If it is CO plus 3, the electronic configuration would be argon 3D64S0. So what we are going to do now, I am going to write here CO3. Alright. So we are having how many d electrons? D electrons are 6. So it is 3d. Okay, then I will write 4s. Then I am going to write 4p. So 1, 2, 3, 4, 5. Now we will fill the electrons. Okay, 6 electrons are there. 1, 2, 3, 4, 5, 6. Now what will happen? Now we have to look at the complex and the ligand we have to see. Now students, all the halogens, okay, fluorine, chlorine, bromine, iodine, they are all weak ligands. Okay, they are all weak ligands. So what happens when weak ligand is present? What will happen? No pairing of electrons will take place. No pairing of electrons in the d orbital. Okay, now so no pairing of electrons in the d orbital. So what we are going to do is, there is no pairing of electron. So in the complex COF6 minus 3 we are having this situation wherein d orbital is there, and 1 2 3 4 5 6, and this is 4s, this is 3d, and here we are having 4p. Now just see how many fluorine atoms are there. 6 are there, and no pairing will take place. So what is going to happen, that each fluorine atom has to accommodate the electrons into the orbitals, but 6 boxes should be there. But how many boxes are we having? 1 2 3 4. So what will happen? The next shell also, next subshell also will be involved. After 4p, 4d comes. Okay, so 1 2 3 4 5. Now what is the requirement, students? Requirement is 6 boxes. So this is the first box which I am getting. Okay, first box, second, third, fourth. Okay, fourth box, fifth and sixth. It means from here till here. All right, so what will be the hybridization? S P 1 2 3 3 and D 2. So total number is 6. So it is octahedral. Geometry is octahedral. Okay, and what is going to happen? The electrons of the fluorine will be donated over here. Okay, in this way we will get the complex. Now let us, oh sorry, this I will not write, only till this we have to write. Now let us discuss what we discussed in case of previous complex. Now unpaired of electrons. Do we have unpaired electrons? Yes, there is presence of unpaired of electron. There is presence of unpaired electrons in the complex. Okay, in the complex. So what will happen if unpaired electrons are there? If unpaired electrons are there and this complex is kept in the magnetic field, all these electrons will be attracted towards the magnetic field. Okay, so we say that this is paramagnetic complex. What is paramagnetic? Paramagnetic means it is going to be attracted. It will be attracted in magnetic field. Okay, now third point, since unpaired electrons are there and they are spinning, okay, they are spinning, see, single electron, so they are spinning, hence we say that this complex is high spin complex. Okay, and what we have written in the previous complex we wrote, it is low spin complex and spin paired complex. Here we are going to write high spin complex, and we can also say it is spin free complex. Okay, I hope you have understood this example also. We have 2 more examples to discuss. Now this is the complex in front of us and we have to answer its geometry, whether it is spin paired, whether it is spin free, low complex, or diamagnetic or paramagnetic. So let us begin with the simple step. We will find out the oxidation number. X minus 4 is equal to minus 2, X is equal to plus 2. So we all know that we have to write down the electronic configuration of nickel ion. Okay, now first we will write the oxidation first we will write down this electronic configuration of nickel when it is in ground state. Okay, so it is Ar, it is 3D8 4s2. Now we have to write Ni plus 2. Okay, see, always remember, when you have to write the electronic configuration of an ion, you have to remove the electrons from the last shell, and last shell is 4s. Okay, how many electrons you will remove? Whatever is the charge on it. So you will remove 2 electrons, so you will get Ar 3D8 4s0. Okay, now we will write down the we will draw the orbitals and boxes we will draw. So we have 4s, and now we remember we are having 4p. 3d 8 it is, so it means we have to fill 1 2 3 4 5 6 7 8. Now please remember chlorine is present, and chlorine is a weak ligand. So Cl is a weak ligand. Okay, it means these orbitals will not be used for the bond formation. Now how many Cl are there? There are 4 Cl. So I'll just write here, we need to have 4 boxes, isn't it? So we have 1 2 3 4. Okay, so it means which hybridization will occur in this compound for nickel? Nickel ion will undergo sp3 hybridization, students. Okay, which hybridization will take place? sp3 hybridization will take place, and the electrons will be donated over here. Okay, now we all know when it is sp3 hybridization, what is the geometry? It is tetrahedral. Okay, what is the geometry? It is tetrahedral. Now if it is tetrahedral, how do we draw tetrahedral? We are having nickel and we are having chlorine. Okay, this bond you show towards nickel. All right, here also this bond you can show towards nickel, you can show towards nickel, you can show towards nickel, and then you are going to write here -2. Now similarly octahedral also, if you remember, in this case octahedral I have told. So how to draw this octahedral? You have to draw in this way the octahedral. In the center what will come? In the center we have to write CO. Okay, now here we are going to write NH3, 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 and one is above NH3, one is below, and then you are going to put the charge on it. Okay, similarly, so have a look at it what I have drawn. Okay, similarly for the next compound also we will write here cobalt, and here F, here F, here F, here also F, one above, one below, and there is a -3 charge. Okay, so now as we have drawn over here, this is what it is, tetrahedral geometry. Now we shall discuss the same parameters here also. Do we have free electrons? Do we have unpaired electrons? Let us see here. Yes students, we are having unpaired electrons. So I will write here presence of unpaired electron. Okay, now if there is presence of unpaired electron, means it is going to get attracted in the magnetic field, so it is paramagnetic in nature. Okay, now after that, if it is paramagnetic in nature, now it is going to be high spin complex. Okay, high spin complex, and yes, it is going to be, we can write here, spin free complex. Okay, now the last complex which we are going to discuss in this video is quite interesting, and it is nickel. Okay, nickel, again nickel I have written, but now we have cyanide, students. Okay, now it is very interesting example for the complexes. So it is Ni is there, NiX, cyanide is what? -1, so -1 into 4, -4 is equal to -2, X is equal to +2. So I write here Ni +2. So what will be the electronic configuration of Ni +2? It is going to be argon 3d8 4s0. Okay, but please remember now, cyanide is a strong ligand. Cyanide is a strong ligand. It is a very strong ligand, and when strong ligand is present, it will lead to pairing of electrons. Okay, pairing of electrons in the D shell. Fine. Now, so let us draw the structure first. Let us draw the orbitals. Okay, so we are having Ni +2 and 3d8 is written. I'll write 3d 1 2 3 4 5, and then we have 4s0, and then we have 4p. Okay, now 3D8 I will draw 2, 3, 4, 5, 6, 7, 8. Okay, now it is a strong ligand which will lead to pairing of electrons. So electron will shift to the inner orbital and we are going to get this. We are going to get shifting of electron is happening. So 1, 2, 1, 2, 1, 2, 1, 2 and we have got one empty 3D orbital. Okay, and I write here 4p. Now how many cyanides have to be accommodated? 4 cyanide have to be accommodated. So this is box 1, box 2, 3 and 4. It means which hybridization will take place? Just see, D is there, D is there, 1D is there, 4s, S is there, P, how many p orbitals are there? 2 are there, no? So students, hybridization in this case is going to be DsP2 and the geometry is going to be square planar. Please remember this. We do have 4 cyanide ions, but because cyanide ion is a strong ligand, pairing has taken place. The orbital has been used, the d orbital has been used. Okay, and the geometry is square planar. So how do I draw square planar? Nickel is there and along the 4 corners we are having cyanide, 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 donating its electron to nickel and the charge on the entire complex is -2. Now yes, we have to discuss whether there is unpair of electron. Unpaired electrons are there? No. There is absence of unpaired electron. Why there is absence of unpaired electrons? Because all the electrons got paired up. See, all the electrons got paired up. Okay, so if all the electrons are paired up, it means this complex is diamagnetic. It is going to repel in the magnetic field. And the third point which is connected with this, if no unpaired electrons are there, what will happen? There is no unpaired electron. All paired electrons are there. So it is a low spin complex. Okay, low spin complex, or it is also known as spin paired complex. So it becomes very easy to identify the hybridization and whether the compound is diamagnetic or not. So in this way you will be getting questions in your exams also. Like suppose you are having ZnCl4, okay, and the question is, students, whether this complex is magnetic or not, or diamagnetic or paramagnetic, or to be very precise, the question is predict the magnetic behavior of this complex. What is the question, students? Predict. Tell that whether it is paramagnetic or it is diamagnetic. Now, it's a tricky question. The question which they are asking, you will be able to solve if you come to know whether there is unpaired electron or not. And how will you solve that? Using hybridization and the entire concept. So quickly let me solve it. X minus 4 is equal to +2. So we are having zinc +2. That is argon is there. So we are having 3D10, 4s0. It is very easy to identify, students, in this case. It is 3D10, isn't it? Means all the orbitals are filled with the electrons and 4s is there. So, this will not come, sorry. So there are only 3 boxes, okay, 4px, 4py, 4pz. So in this case 4 chlorine atoms will come, so we need 4 boxes, 1 2 3 4. Okay, so hybridization is going to be sp3, but that is not our main area of interest. Our area of interest is whether it is magnetic, paramagnetic or diamagnetic. Now you just see all the electrons are paired, it means this complex is diamagnetic. So same concept can be asked in different manner also. I hope you were able to understand the basics. Okay, this first example was the octahedral complex, second example was also octahedral complex, third actually was tetrahedral complex, and fourth was